The F-22 Raptor has never lost a single air-to-air engagement, maintaining a perfect 108-0 kill ratio in combat exercises. The MiG-21 became the most produced supersonic fighter in history, with over 11,000 built. The F-15 Eagle achieved 104 victories with 0 combat losses across 5 decades of service. These aren't just statistics, they're the legacy of the most dominant fighter aircraft ever created. From Cold War legends to modern stealth monsters, these 10 warbirds redefined aerial combat and shaped the future of military aviation. F-4 Phantom II, the Double Ugly Legend. A fighter so ugly it earned the nickname Double Ugly became the most produced American supersonic military aircraft in history, with 5,195 built between 1958 and 1981. The McDonnell Douglas F-4 Phantom II proved that raw power could overcome questionable aesthetics. This twin-engine beast could carry over 18,000 pounds of weapons on 9 external hardpoints, while reaching speeds exceeding Mach 2.2. Its cavernous air intakes and drooped nose gave it an ungainly appearance, but the Phantom's performance spoke louder than its looks. The aircraft set 15 world records for in-flight performance, including absolute speed and altitude records. The F-4's combat debut came during the Vietnam War, where it served as the principal air superiority fighter for all 3 U.S. services. Every American pilot who became an ace during Vietnam, 5 total, achieved their status flying Phantoms. The aircraft's versatility allowed it to excel in air-to-air combat, ground attack, and reconnaissance missions. What made the Phantom revolutionary was its multi-role capability decades before the term became common. Initially designed without an internal cannon, later variants incorporated the M61 Vulcan rotary cannon after Vietnam combat experience revealed the need for close-range firepower. The F-4's adaptability kept it relevant across multiple conflicts and with numerous allied nations. Despite its unconventional appearance, the Phantom became a signature aircraft of the Cold War, serving with 11 countries besides the United States. Its combination of speed, payload capacity, and technological advancement established the template for modern multi-role fighters. MiG-21, the People's Fighter. One aircraft has been flown by approximately 60 countries across 4 continents and still serves many nations 7 decades after its maiden flight. The Mikoyan-Gurevich MiG-21 Fishbed became the most produced supersonic jet aircraft in aviation history, proving that simple, effective design trumps complexity. The MiG-21's pencil-shaped fuselage and delta wing configuration created an aircraft that was both affordable and deadly. Its nickname Balalaika came from its planform resembling the Russian stringed instrument, while Vietnamese pilots called it On Bak, or Silver Swallow. This small fighter could reach Mach 2.05 and climb at 225 meters per second. What made the MiG-21 extraordinary was its operational simplicity. Unlike complex Western fighters requiring extensive maintenance, the MiG-21 was designed for rapid turnaround and minimal ground support. Its single Tumansky engine and straightforward systems allowed less developed nations to operate sophisticated supersonic fighters. The aircraft's combat record spans dozens of conflicts worldwide. During the Vietnam War, North Vietnamese MiG-21s proved formidable opponents against American F-4 Phantoms and F-105 Thunder Chiefs. The fighter's small size and high speed made it difficult to detect and engage, while its heat-seeking missiles proved effective in close combat. The MiG-21's longevity stems from continuous upgrades and modifications. Modern variants like the MiG-2193 incorporate advanced avionics and weapon systems while maintaining the original airframe's proven characteristics. This evolutionary approach kept the Fishbed relevant across multiple generations of aerial warfare. F/A-18 Hornet, the Carrier Warrior. The first aircraft designed from the ground up to be both a fighter and attack platform, the McDonnell Douglas F/A-18 Hornet revolutionized naval aviation by combining air-to-air and air-to-ground capabilities in a single airframe. This twin-engine marvel proved that versatility didn't require compromise. Entering service in 1983, the Hornet replaced both the F-4 Phantom and A-7 Corsair in U.S. Navy and Marine Corps service. Its unique design featured canted vertical stabilizers, leading-edge extensions, and a digital fly-by-wire control system that provided exceptional maneuverability at high angles of attack. The aircraft could remain controllable in flight regimes that would stall conventional fighters. The Hornet's combat debut during Operation Desert Storm demonstrated its revolutionary dual-role capability. Hornets shot down enemy fighters and bombed ground targets within the same mission, proving the concept of true multi-role operations. Aircraft that took direct hits from surface-to-air missiles successfully recovered, were quickly repaired, and flew again the next day, cementing the Hornet's reputation for survivability. Powered by twin General Electric F404 engines producing 17,750 pounds of thrust each with afterburner, the Hornet could reach supersonic speeds while carrying substantial weapons loads. Its 410-square-foot wing area and advanced flight controls provided the agility needed for both air combat and precision ground attack missions. The FA-18's carrier-based design requirements created an aircraft optimized for harsh operating conditions. Its robust landing gear, corrosion-resistant materials and folding wings made it ideal for naval operations, while its reliability and maintainability kept operational costs manageable throughout its service life. Dassault Rafale, the French omni-role master. While other nations built specialized fighters, France created an aircraft capable of performing every mission from air superiority to nuclear deterrence in a single sortie. The Dassault Rafale represents the pinnacle of European fighter design, combining advanced technology with operational flexibility. The Rafale's distinctive canard delta configuration provides exceptional maneuverability, allowing the aircraft to withstand forces from -3.6 G to +9 G in normal operations. Its aerodynamically unstable design requires digital fly-by-wire controls to maintain stability, but this instability provides the agility needed for modern air combat. The aircraft can fly as slowly as 15 knots during training missions while maintaining control. What really sets the Rafale apart is its domestically developed technology. The RBE-2 active electronically scanned array radar, Optronique Secteur frontal infrared search and track sensor, and direct voice input systems were all created specifically for the Rafale program. This technological independence allows France to upgrade and modify the aircraft without foreign restrictions. The Rafale's omni-role capability means it can switch between air-to-air and air-to-ground missions during flight without returning to base. Its 14 hardpoints can carry up to 21,000 pounds of weapons, including Meteor air-to-air missiles, Storm Shadow cruise missiles, and ASMP nuclear weapons. This flexibility makes each Rafale equivalent to multiple specialized aircraft. The aircraft's naval variant, the Rafale M, demonstrates French engineering excellence. Despite being carrier-capable, it retains 95% commonality with land-based versions and cannot fold its wings, a design decision enabled by France's nuclear-powered Charles de Gaulle carrier. This commonality reduces training and maintenance costs while maximizing operational flexibility. Eurofighter Typhoon, the European collaboration. 4 European nations overcame decades of rivalry to create a fighter that could challenge American air superiority, resulting in the Eurofighter Typhoon, a twin-engine marvel that combines the best of British, German, Italian, and Spanish aerospace technology. This multinational collaboration produced one of the world's most capable air superiority fighters. The Typhoon's development began in 1983 as the Future European Fighter Aircraft Program, originally including France before disagreements over design authority, led to France's withdrawal to develop the Rafale independently. The remaining partners created a consortium of Airbus, BAE Systems, and Leonardo that continues to manage the program today. Powered by 2 engines producing 150,000 horsepower combined, the Typhoon can reach Mach 2.35 and climb to 11,000 meters in just 2 minutes. This exceptional performance makes it ideal for quick reaction alert missions, intercepting intruders before they can penetrate national airspace. The aircraft's canard delta configuration provides the agility needed for modern air combat scenarios. The Typhoon's combat record includes operations in Libya, where Royal Air Force aircraft participated in airstrikes destroying tanks in 2011 as their combat debut. The aircraft's precision strike capability, combined with its air superiority mission, demonstrates the multi-role flexibility that defines modern fighter design. With over 850,000 flight hours accumulated and 680 aircraft ordered by 9 nations, the Typhoon forms the backbone of European air defense. Export customers including Saudi Arabia, Oman, Qatar, Kuwait, and Austria demonstrate the aircraft's international appeal and operational effectiveness across diverse operating environments. F-15 Eagle, the undefeated champion. No fighter aircraft in history has achieved what the McDonnell Douglas F-15 Eagle accomplished. 104 air-to-air victories with 0 combat losses over 5 decades of service. This twin-engine air superiority fighter established a combat record that remains unmatched in modern aviation. Designed in response to the Soviet MiG-25 threat, the F-15 first flew in 1972 and entered service in 1976. Its massive twin Pratt and Whitney engines and advanced radar gave it capabilities that overwhelmed contemporary opponents. The aircraft's not a pound for air-to-ground design philosophy created a pure air superiority fighter optimized for one mission, controlling the skies. The F-15's combat debut came with the Israeli Air Force in 1979, where it quickly established its dominance. During the 1982 Lebanon War, Israeli F-15s achieved multiple victories against Syrian aircraft without suffering a single loss. This pattern continued in U.S. service during the Gulf War, where F-15Cs accounted for 34 of 37 Air Force air-to-air kills. What makes the F-15 extraordinary is its longevity. 50 years after its first flight, the aircraft remains in production with the F-15X variant. This latest version incorporates modern avionics, fly-by-wire controls, and advanced electronic warfare systems while maintaining the proven airframe that has never been defeated in air combat. The F-15's weapons capacity is legendary. The F-15EX can carry up to 22 air-to-air missiles, more than any other fighter in production. Combined with its APG-82 AESA radar and advanced electronic warfare suite, the modern Eagle remains a formidable opponent for any adversary aircraft. Sukhoi Su-27, the Soviet Sky Dancer. Soviet engineers created a fighter so agile it could perform maneuvers that, honestly, seemed to defy physics, challenging Western assumptions about aircraft design, and establishing the Sukhoi Su-27 flanker as arguably the finest air superiority platform of the 20th century. This massive twin-engine fighter combined size with grace in ways that really redefined aerial combat. Development began in 1969 as a direct response to the American F-15 Eagle, with chief designer Mikhail Simonov gradually refining the design into a masterpiece of aerodynamic engineering. The Su-27's distinctive shape, with its long fuselage, widely spaced engines, and graceful curves, created an aircraft that was both beautiful and deadly. The Su-27's performance specifications read like fantasy: Mach 2.35 maximum speed, 18,500-meter service ceiling, and a 3,530-kilometer range. More importantly, its thrust-to-weight ratio of 1.07, with partial fuel load, gave it acceleration and climb performance that matched or exceeded any Western fighter. The aircraft could pull plus 9G maneuvers while maintaining control at extreme angles of attack. What truly set the Su-27 apart was its maneuverability. The aircraft could perform the Cobra maneuver, pulling its nose up to 90 degrees or more while maintaining forward flight, demonstrating control authority that Western fighters just couldn't match. This super maneuverability came from its relaxed stability design and powerful flight control system. The Su-27's combat record, while limited, proved its effectiveness. Ethiopian Su-27s shot down 5 Eritrean MiG-29s during the Eritrean-Ethiopian War, demonstrating the flanker's superiority even over its intended partner aircraft. The Su-27's influence extends through its numerous variants, including the Su-30, Su-33, Su-34, and Su-35, each optimizing the basic design for specific missions. F-22 Raptor, the Invisible Predator. The F-22 Raptor, known as the Invisible Predator, achieved something truly unprecedented in modern aviation: a perfect combat record of 108 victories and 0 losses during realistic combat exercises. The Lockheed Martin F-22 Raptor stands as the absolute pinnacle of American aerospace technology, blending stealth, supercruise, and maneuverability in ways that, honestly, just redefined what air superiority means. The F-22's development kicked off in 1981 as the Advanced Tactical Fighter Program, with Lockheed Martin's design coming out on top in 1991. Its revolutionary mix of radar-absorbing materials, thrust vectoring, and integrated avionics gave it capabilities that, just a few decades earlier, would have seemed impossible. Stealth technology makes the F-22 almost invisible to enemy radar, allowing it to engage targets without ever being detected. And when you pair that with its ability to super cruise at Mach 1.5 without using afterburners, the Raptor can show up anywhere in the battle space, totally without warning. Its thrust vectoring engines give it maneuverability that outclasses even the most agile conventional fighters out there. But what really sets the F-22 apart is its combat systems integration. The radar, weapons control, and electronic warfare systems all work together as one seamless unit, providing pilots with situational awareness that gives them a huge advantage. During Exercise Northern Edge in 2006, F-22S racked up a 108-0 kill ratio against top F-15, F-16, and F-18 adversaries, all while maintaining a 97% mission capability rate. Production limitations make the F-22 pretty exclusive. Only 187 operational aircraft were built before the program wrapped up in 2012. This scarcity, along with export restrictions to protect its advanced tech, ensures the Raptor stays America's ultimate air superiority weapon. The aircraft's capabilities are so advanced, it's expected to remain the U.S. Air Force's premier fighter well into the 2040s. F-16, Fighting Falcon, the Global Guardian. The F-16 Fighting Falcon, often called the Global Guardian, is the one fighter aircraft that serves with more air forces around the world than any other, proving that, sometimes exceptional design really does transcend national boundaries. The general dynamics. F-16. Fighting Falcon became the most widely used fighter jet on the planet, with over 4,600 built and flown by more than 25 nations. The F-16's revolutionary design brought fly-by-wire flight controls to production fighters, which allowed an aerodynamically unstable aircraft to pull off some pretty incredible maneuvers. Its side-mounted control stick and reclined pilot seat helped reduce G-force effects, letting pilots handle sustained high G turns that would knock out pilots in more conventional jets. The bubble canopy offered 360-degree visibility that was just unmatched by any other fighter at the time. What really made the F-16 special was its lightweight design philosophy. Unlike the big, heavy F-15, the Fighting Falcon was all about being lightweight and affordable, but still able to outmaneuver bulkier opponents. Its single Pratt & Whitney or General Electric engine gave it a thrust-to-weight ratio over 1:1, so it could accelerate and climb faster than a lot of larger aircraft. The F-16's combat record covers conflicts all over the globe, from the Middle East to the Balkans. Israeli F-16S famously destroyed Iraq's Osirak nuclear reactor in 1981, showing off its precision strike ability, and during the Gulf War, F-16S flew more sorties than any other coalition aircraft, proving just how reliable and effective they really are. Continuous upgrades have kept the F-16 in the fight for 4 decades now. Modern versions feature AESA radars, advanced electronic warfare systems, and precision-guided weapons. The basic design is still so solid that new F-16S are still being built today, with the latest Block 70 and 72 models representing the very best in single-engine fighter tech. FA-18EF Super Hornet, the carrier evolution. The F/A-18E/F Super Hornet, known as the Carrier Evolution, is where Boeing took the proven Hornet design and turned it into something completely new. The Super Hornet is actually 25% larger than its predecessor, even though it shares the same designation. This leap forward gave us a fighter that combines the original Hornet's reliability with capabilities that can actually rival dedicated air superiority fighters. The Super Hornet was developed to address the original FA-18's limitations, all while keeping its proven strengths. The bigger airframe holds more fuel, which means it has the range needed for deep strike missions. Its more powerful F-414 engines deliver 22,000 pounds of thrust each, giving it supersonic performance even with heavy weapons loads. What really sets the Super Hornet apart is its electronic warfare version, the EA-18G Growler. It uses the same airframe but brings specialized jamming capabilities to the table. This means carrier air wings can keep their electronic warfare edge without needing totally different aircraft types, making logistics and training a whole lot simpler. The Super Hornet has seen combat in Iraq, Afghanistan, and Syria, where its precision strike power and survivability have been absolutely essential. Its advanced APG-79 AESA radar and integrated defensive systems give pilots the situational awareness they need in today's high-threat environments. Plus, its ability to serve as an aerial refueling tanker adds another layer to its multi-role flexibility. Even though it's called an upgraded Hornet, the Super Hornet actually shares less than 10% of its parts with the original FA-18. This major redesign created a jet that really performs like a new generation fighter, while still keeping the traits that made the Hornet so successful. The Super Hornet continues serving as the U. These 10 legendary fighters, honestly, they represent the evolution of aerial warfare from the Cold War right up to the cutting edge of the modern era. Every one of these aircraft pushed the boundaries of what was possible, from the Phantom's raw power to the Raptor's stealth revolution. They've defended nations, won wars, and inspired generations of aerospace engineers to reach even higher. The future of fighter aviation is going to build on the solid foundations these warbirds established. So which of these sky legends impressed you the most? Go ahead and share your thoughts below, smash that like button, and subscribe to Future Facts for more incredible stories about aviation excellence. Until next time, keep reaching for the sky. A mysterious cigar-shaped object that baffled scientists in 2017 has returned to our solar system. And this time, it's transmitting signals that NASA doesn't want you to hear. Joe Rogan recently dropped a bombshell on his podcast, claiming that Oumuamua, the first confirmed interstellar visitor, is back and actively communicating with Earth. But here's the shocking part. Government agencies are allegedly suppressing the evidence. What are these objects really trying to tell us? Why is the scientific establishment so desperate to maintain the natural explanation narrative? The answers might terrify you. The original Oumuamua mystery, a cosmic anomaly. What if I told you that in 2017, something entered our solar system that shouldn't exist according to our understanding of physics? October 19, 2017, changed everything we thought we knew about our place in the universe. Astronomers at the Haleakala Observatory in Hawaii detected a dark, elongated object hurtling through our solar system at impossible speeds. They named it Oumuamua, Hawaiian for scout or messenger from afar arriving first. This wasn't just another asteroid. Oumuamua measured roughly 1,300 feet long but only 130 feet wide, giving it a cigar-like shape unlike anything in our solar system. Its surface was dark red, suggesting billions of years of cosmic radiation exposure during its journey through interstellar space. But the real mystery began when scientists tried to understand its behavior. Traditional asteroids and comets follow predictable paths governed by gravity and solar radiation. Oumuamua didn't. It accelerated as it moved away from the sun without displaying any visible comet tail or gas emissions that would explain the propulsion. This non-gravitational acceleration violated our understanding of celestial mechanics and sparked intense debate in the scientific community. The Breakthrough Listen investigation, searching for signals. Imagine the world's most powerful radio telescope suddenly turning toward a single mysterious object in space. That's exactly what happened when Oumuamua's strange behavior captured global attention. The Breakthrough Listen project, a $100 million initiative to search for extraterrestrial intelligence, immediately turned their most sensitive equipment toward the mysterious visitor. The Green Bank Telescope in West Virginia, one of the world's most sensitive radio receivers, began monitoring Oumuamua for any artificial signals. The investigation wasn't casual curiosity. Breakthrough Listen's scientists recognized that if Oumuamua was indeed artificial, it might be transmitting data back to its creators or attempting to communicate with Earth. The telescope listened across multiple radio frequencies from 1 to 12 gigahertz, capable of detecting signals as weak as a cell phone transmission from Oumuamua's distance. During the first observation session, the Green Bank telescope recorded a staggering 90 terabytes of raw data, enough information to fill 23 high-end computers. While no obvious artificial signals were detected in the initial analysis, the sheer volume of data required months of processing. Scientists had to filter out Earth-based interference, satellite communications, and natural cosmic background radiation to isolate any potential extraterrestrial transmissions. Joe Rogan's explosive NASA accusations, the cover-up claims. If this was just a rock, why is everyone so nervous about it? This explosive question from Joe Rogan has sent shockwaves through both the scientific community and his massive audience. On a recent episode of The Joe Rogan Experience, the podcast host made stunning accusations that NASA has been deliberately withholding crucial information about Oumuamua and its potential extraterrestrial origins. Rogan's accusations center on what he describes as NASA's rushed dismissal of the artificial hypothesis and their apparent reluctance to conduct more thorough investigations. He points to the agency's quick pivot to natural explanations, including the controversial hydrogen iceberg theory, as evidence of a deliberate cover-up designed to prevent public panic. The podcast host also highlighted the suspicious timing of certain NASA announcements and the agency's apparent pressure on scientists like Avi Loeb to tone down their extraterrestrial theories. According to Rogan, this pattern of behavior suggests institutional knowledge of Oumuamua's true nature, and a coordinated effort to suppress that information from the public. His comments struck a chord with millions of listeners who have long suspected government agencies of hiding evidence of alien contact, raising uncomfortable questions about scientific transparency. The new interstellar visitor, 3I Atlas, arrives. Just when you thought the Oumuamua mystery was fading into history, the universe delivered another cosmic curveball. In July 2025, astronomers made another startling discovery that has reignited all the old questions about interstellar visitors. The Atlas survey system detected a new interstellar object designated 3I/Atlas, officially making it only the third confirmed visitor from beyond our solar system. Unlike its predecessor, 3I/Atlas displays clear cometary activity, complete with a visible coma and tail as it approaches the Sun. At an estimated 12 miles in diameter, it's significantly larger than Oumuamua and much brighter, allowing for extended observation periods that just weren't possible with the original mysterious visitor. What makes 3I/Atlas particularly intriguing is its trajectory and timing. The object is approaching from the direction of the galactic center, following a path that some researchers suggest could be artificially controlled. Its arrival so soon after Oumuamua has led to speculation about whether these objects might be related, perhaps part of a larger reconnaissance mission or communication network. Early observations have revealed some disturbing similarities to Oumuamua's anomalous behavior, including unexpected acceleration patterns that challenge conventional explanations. The signal detection claims what NASA won't tell you. What if I told you that radio telescopes have been picking up structured signals from interstellar objects, but the data is being classified rather than published? According to sources close to the Breakthrough Listen project and other SETI initiatives, there's more to the Oumuamua story than the public has been told. While official reports state that no artificial signals were detected, insiders claim that certain anomalous readings were dismissed or classified rather than investigated further. These alleged signals weren't the obvious hello messages that science fiction might suggest. Instead, they reportedly consisted of subtle patterns in radio emissions, structured data bursts that occurred during specific phases of Oumuamua's rotation, and frequency modulations that seemed too organized to be natural phenomena. The complexity of these potential communications required sophisticated analysis that may have revealed their artificial nature. Joe Rogan's sources suggest that when these signals were first detected, they triggered immediate classified briefings with government officials and military personnel. The decision was allegedly made to suppress the findings to prevent public panic, while further investigation continued in secret. Even more disturbing are reports that similar signals have been detected from the new 3I/Atlas object, suggesting an ongoing communication attempt. The Harvard connection, Avi Loeb's controversial stand. One Harvard professor dared to say what others wouldn't: Oumuamua might be alien technology, and his career nearly ended because of it. Dr. Avi Loeb's willingness to publicly discuss Oumuamua's potential artificial origins made him both a hero to UFO enthusiasts and a pariah within certain scientific circles. As the chair of Harvard's astronomy department and former director of the Institute for Theory and Computation, Loeb's credentials were impeccable, making his extraterrestrial hypothesis impossible to dismiss as fringe science. His argument was elegantly simple. When faced with an object that behaves unlike anything in our solar system, scientists should consider all possibilities, including artificial origins. The scientific establishment's reaction to Loeb's hypothesis was swift and harsh. Colleagues criticized his sensationalism, funding agencies questioned his research priorities, and academic journals became reluctant to publish papers exploring the artificial possibility. This institutional pressure revealed the scientific community's deep discomfort with extraterrestrial explanations, even when supported by evidence. Loeb's appearance on Joe Rogan's podcast brought his theories to a massive mainstream audience, bypassing traditional academic gatekeepers. During the interview, he detailed the specific characteristics that made Oumuamua unique, and explained why the artificial hypothesis deserved serious consideration rather than reflexive dismissal. The physics of impossible objects. Why natural explanations fail. The scientific community's attempts to explain Oumuamua through natural processes have produced theories so exotic they make alien technology seem reasonable by comparison. The most prominent explanation suggests that Oumuamua was a hydrogen iceberg, a chunk of frozen hydrogen that sublimated invisibly as it approached the sun, providing the thrust needed for its observed acceleration. But, this hydrogen iceberg theory faces numerous problems that would make any physicist uncomfortable. Hydrogen ice is extremely fragile and would likely disintegrate during the millions of years required for interstellar travel. Plus, the sublimation process would need to occur at precisely the right rate and direction to produce Oumuamua's observed acceleration without creating a visible coma or tail. Alternative natural explanations are equally problematic. Some scientists suggested that Oumuamua might be a dust bunny held together by weak forces, but this couldn't account for its structural integrity during close solar approach. Others proposed that it was a fragment of a larger body destroyed by tidal forces. But this doesn't explain its unique shape or behavior. The failure of natural explanations becomes more apparent when considering Oumuamua's trajectory. The object's path through our solar system was nearly perfect for a reconnaissance mission, providing optimal viewing angles of all major planets while maintaining a safe distance from gravitational capture. The communication theory. Decoding alien messages. What if advanced civilizations don't send obvious radio signals but instead hide their messages in the behavior of seemingly natural objects? If Oumuamua and similar objects are indeed artificial, their purpose might extend beyond simple reconnaissance. Advanced extraterrestrial civilizations would likely use sophisticated communication methods that appear natural to primitive observers, basically hiding their messages in plain sight. The communication theory suggests that these interstellar visitors serve as relay stations or message carriers, transmitting information across vast galactic distances. Their unusual trajectories and behaviors might be carefully choreographed to deliver specific data to civilizations capable of recognizing the artificial patterns. This approach would explain why obvious radio signals weren't detected. The real messages might be encoded in the object's physical properties, orbital mechanics, or subtle electromagnetic emissions. The information could be stored in the visitor's material composition, revealed through spectroscopic analysis, or transmitted through gravitational wave patterns that are just too sophisticated for current human technology to decode. The timing of these visits might also be significant. Oumuamua arrived just as humanity developed the technological capability to detect and study interstellar objects, suggesting that our cosmic neighbors might be responding to our recent technological advancement. The rapid appearance of 3I Atlas could indicate an escalation in this communication attempt. The government response. Classified implications. The moment scientists confirmed Oumuamua's anomalous behavior, something unprecedented happened behind closed doors that the public was never meant to know about. The potential discovery of extraterrestrial technology visiting our solar system would trigger immediate classified responses from government agencies worldwide. According to Joe Rogan's sources, this classified response began immediately after Oumuamua's strange acceleration was confirmed. Emergency briefings were conducted for senior government officials, and contingency plans were activated to manage potential public disclosure. The decision to suppress evidence of artificial origins allegedly came from the highest levels of government. The reasoning behind this cover-up involves concerns about social stability, economic disruption, and religious upheaval that might result from confirmed alien contact. Government analysts reportedly concluded that humanity wasn't psychologically prepared for such revelations, and that gradual disclosure would be necessary to prevent panic and social collapse. This classified response would explain the unusual pressure placed on scientists to avoid extraterrestrial explanations and the rapid development of alternative theories, regardless of their scientific validity. It would also account for the apparent coordination between different space agencies and research institutions in promoting the natural explanation narrative. The arrival of 3I Atlas has reportedly triggered similar classified responses, with government officials now facing the possibility that these visits represent an ongoing phenomenon. The future of disclosure. What happens next? We're standing at the threshold of the most significant moment in human history, and most people don't even realize it. As more interstellar objects are detected and their artificial nature becomes increasingly difficult to deny, the question isn't whether extraterrestrial contact will be revealed, but when and how. The scientific community's credibility is already strained by their increasingly exotic natural explanations, and public skepticism is growing thanks to voices like Joe Rogan's. The next phase of this cosmic drama will likely involve more sophisticated detection methods and analysis techniques that make artificial origins undeniable. Government disclosure might come gradually, beginning with acknowledgement that some objects display anomalous characteristics before eventually admitting their artificial nature. This controlled revelation would allow society to adjust slowly to the reality of extraterrestrial intelligence while maintaining institutional authority and social stability. Alternatively, the truth might emerge through leaked classified documents, whistleblower testimonies, or independent research that bypasses official channels. The internet age makes information suppression increasingly difficult, and the growing number of people involved in interstellar object research makes leaks more likely. The ultimate revelation that humanity is not alone in the universe will mark the beginning of a new era in human history. Whether we're ready or not, our cosmic neighbors appear to be making contact, and their messages are becoming impossible to ignore. The mystery of Oumuamua and its potential alien origins represents more than just another space anomaly. It's a test of humanity's readiness to join a larger cosmic community. Joe Rogan's explosive accusations about NASA's cover-up might sound like conspiracy theory, but the evidence supporting artificial origins continues to mount with each new discovery. The cosmic messengers are here, and their signals are becoming impossible to ignore. What do you think these mysterious visitors are really trying to tell us? Share your thoughts below, hit that like button, and subscribe to Future Facts for more mind-bending revelations about our cosmic neighbors. Until next time, keep watching the skies. Deep beneath the Swiss-French border, CERN's Large Hadron Collider has achieved something that honestly sounds like science fiction, creating conditions so extreme they may have briefly formed microscopic black holes. Now, these aren't the massive cosmic devourers we know from space, but quantum-scale phenomena that exist for mere fractions of a second before evaporating in bursts of exotic particles. What scientists discovered in the aftermath of these experiments has, well, profound implications for our understanding of extra dimensions, quantum gravity, and the fundamental structure of reality itself. The theoretical foundation. The real secret behind microscopic black hole creation lies in some pretty cutting-edge theories about the nature of space itself. In standard physics, creating a black hole would require concentrating energy equivalent to around 10 to the 19th GeV, way beyond what any human-made machine could ever achieve. But theories involving extra dimensions like the Arcani-Hammett-Dimopoulos-Diwali or ADD model suggest that gravity might actually leak into hidden spatial dimensions while other forces stay confined to our familiar three-dimensional space. This would explain why gravity seems so much weaker than electromagnetic or nuclear forces. It's not inherently weak, but rather it's diluted across extra dimensions we just can't perceive. If this is true, it dramatically lowers the energy threshold for black hole formation, potentially bringing it within reach of the LHC's 13 to 14 TeV collision energies. The mathematical framework for these ideas really started to take shape around 1998 to 2000, when physicists like Nima Arcani-Hamed, Savas Dimopoulos, and Gia Diwali proposed that our universe might have more than the four dimensions we experience. These extra dimensions would be compactified, curled up so tightly at every point in space that we can't detect them in everyday life, yet they fundamentally alter how physics works at the tiniest scales. CERN's experimental setup. The Large Hadron Collider represents, honestly, humanity's most ambitious attempt to recreate conditions from the earliest moments of the universe. Built in a 27-kilometer tunnel beneath the Swiss-French border, the LHC accelerates protons to 99.9999991% of light speed before smashing them together with unprecedented energy. The Atlas and CMS detectors, which are just massive instruments containing millions of sensors, capture the spray of particles created in these violent collisions. When protons collide at such extreme energies, they create conditions similar to those existing just a fraction of a second after the Big Bang, when temperatures exceeded 1,000,000,000 degrees. The detectors track every particle emerging from these collisions, always on the lookout for signatures of new physics beyond the standard model. The CMS, or Compact Muon Solenoid experiment, has been specifically searching for microscopic black hole signatures ever since the LHC's early runs. These searches focus on identifying the distinctive particle showers that would result from black hole evaporation through Hawking radiation. The detectors have to distinguish between ordinary particle collisions and the unique signatures that would indicate space-time itself has temporarily collapsed into a microscopic black hole. The search for microscopic black holes. The CMS collaboration has, conducted extensive searches for microscopic black hole production throughout the LHC's operational history. During the 2010 run at 7 TeV Center of Mass Energy, scientists analyzed proton-proton collision data, looking for the distinctive signatures that would indicate black hole formation and subsequent evaporation. According to theoretical predictions, if microscopic black holes formed, they would immediately evaporate through Hawking radiation, producing a characteristic spray of subatomic particles. These particles would create specific energy patterns detectable by the CMS detector's sophisticated sensors. The evaporation process would happen in about 10 to the minus 27th seconds, an almost incomprehensibly brief moment. The search parameters focused on black hole masses ranging from 3.5 to 4.5 TeV, based on various theoretical models involving extra dimensions. Scientists looked for events where particles emerged in patterns consistent with black hole decay, including high-energy jets and unusual particle multiplicities that just wouldn't occur in standard particle collisions. While no definitive evidence for microscopic black holes has been confirmed in peer-reviewed publications, the searches have provided valuable constraints on theoretical models and continue to refine our understanding of what might be possible at these extreme energy scales. Stephen Hawking's encouragement. In 2009, renowned physicist Stephen Hawking visited CERN's underground facilities and made a remarkable statement that really captured the scientific community's imagination. While touring the Atlas detector with CERN Director General Rolf Hoyer, Hawking expressed his hope that the LHC would successfully create black holes, saying with characteristic enthusiasm, "I hope you'll make black holes." This wasn't just scientific curiosity. Hawking understood that creating microscopic black holes would represent a fundamental breakthrough in physics. Such an achievement would provide the first experimental test of quantum gravity, the long-sought theory unifying Einstein's general relativity with quantum mechanics. It would also offer direct evidence for extra dimensions and validate decades of theoretical work. Hawking's encouragement came despite ongoing public concerns about LHC safety. A lawsuit had actually been filed in the United States expressing fears that the collider might create dangerous black holes or exotic matter that could destroy Earth. The lawsuit was eventually dismissed on grounds that speculative fear of future harm does not constitute an injury in fact sufficient to confer standing. Hawking's support helped legitimize the scientific importance of these experiments, emphasizing that any microscopic black holes created would evaporate instantly through the radiation process he had theorized decades earlier. The Hawking radiation process. The theoretical framework for microscopic black hole evaporation relies on Stephen Hawking's groundbreaking work from the 1970s, which showed that black holes aren't completely black, but emit radiation through quantum effects at their event horizons. This process, known as Hawking radiation, happens because quantum mechanics allows particle-antiparticle pairs to spontaneously appear near the black hole's boundary. In this process, one particle from each pair falls into the black hole while the other escapes, carrying away energy and causing the black hole to gradually lose mass. For microscopic black holes, this evaporation happens almost instantaneously. The smaller the black hole, the faster it evaporates. A black hole with the mass of a proton would disappear in about 10 to the minus 27th seconds. The evaporation produces a distinctive signature, a burst of particles with specific energy distributions and correlations. These particles would include photons, electrons, muons, and potentially exotic particles not found in the standard model. The exact composition depends on the black hole's mass and the number of extra dimensions through which gravity can propagate. This rapid evaporation is crucial for safety. Any microscopic black holes created at the LHC would disappear before they could interact significantly with surrounding matter, making them scientifically fascinating but, practically harmless. Recent experimental developments. In 2024, CERN's High Radmat facility achieved a significant breakthrough by creating high-density electron-positron plasma beams that mimic the jets of matter and antimatter streaming from astrophysical black holes. The Fireball collaboration, led by researchers including Gianluca Sari, successfully produced plasma containing around 10 trillion electron-positron pairs, the highest density ever achieved in laboratory conditions. This experiment doesn't create actual black holes, but it recreates the extreme plasma conditions found in black hole jets, providing insights into how these cosmic phenomena behave. The research helps validate theoretical models of black hole physics using real experimental data rather than just computer simulations. Meanwhile, the search for actual microscopic black holes continues with increasingly sophisticated analysis techniques. Machine learning algorithms now scan collision data for subtle patterns that might indicate black hole formation and evaporation. These AI systems can detect correlations in particle tracks that human researchers might easily miss, potentially revealing evidence of quantum gravitational effects. The CMS and ATLAS collaborations continue refining their search strategies, looking for soft, unclustered energy patterns. Subtle energy signals that don't form clear particle groups, but might indicate interactions with hidden dimensions or exotic physics beyond the standard model. Implications for extra dimensions. So, the search for microscopic black holes represents more than just an attempt to create exotic objects. It's actually a direct probe of spacetime's fundamental structure. If these black holes can be created at LHC energies, it would provide the first experimental evidence for extra dimensions beyond the three spatial dimensions we experience every day. The existence of extra dimensions would totally revolutionize our understanding of physics, and could explain why gravity appears so much weaker than the other fundamental forces. It would also suggest that our familiar three-dimensional space is just a brain embedded in a higher dimensional reality, with gravity able to propagate through the full multidimensional space, while other forces remain confined to our brain. Different theoretical models predict different numbers of extra dimensions, from one additional dimension in some scenarios, to 6 or even more in others. The energy threshold for black hole creation, and the characteristics of their evaporation, would reveal crucial information about these hidden aspects of reality. And, such discoveries would also have profound implications for cosmology, potentially explaining dark matter and dark energy as manifestations of physics operating in extra dimensions. So, the microscopic black holes created at CERN might provide the first laboratory window into these cosmic mysteries. Safety considerations and natural experiments. So, before launching any high-energy experiments, CERN scientists, really took their time with extensive safety assessments, especially when it came to concerns about microscopic black hole creation. The main argument for safety actually comes straight from nature. Cosmic rays are constantly bombarding Earth's atmosphere with energies that, honestly, far exceed anything the LHC could ever produce. Ultra-high-energy cosmic rays can carry energies up to 10 to the 20th power electron volts, which is, wow, about 10 million times higher than the LHC's maximum energy. These particles have been creating natural collisions with atmospheric nuclei continuously, and Earth has experienced roughly 1 million of these impacts per square kilometer every year for its entire 4.5 billion year history. If microscopic black holes posed any danger at the energies CERN explores, nature would have already run these experiments countless times over. The simple fact that Earth is still here shows that any black holes created at these energy scales either evaporate harmlessly through Hawking radiation, or are just way too small to interact significantly with ordinary matter. And even if Hawking's theory turned out to be wrong and microscopic black holes didn't evaporate, they'd still pose no threat because of their incredibly weak interaction with normal matter. Such objects would just pass through Earth almost without any effect, kind of like the trillions of neutrinos that pass through our bodies every second without us ever noticing. Future prospects and upgraded searches. Looking ahead, as the LHC keeps running with upgraded detectors and higher luminosity, the search for microscopic black holes is, becoming more and more sophisticated. The high luminosity LHC, which is expected to start up in the late 2020s, will actually provide 10 times more collision data, and that will dramatically improve our sensitivity to rare phenomena. Future experiments are going to use advanced artificial intelligence to analyze all that collision data, searching for subtle patterns that could hint at black hole formation. These AI systems can process vast amounts of data at the same time, spotting correlations and anomalies that would honestly be impossible for human researchers to catch manually. Then there's the proposed Future Circular Collider, a 100-kilometer ring that would operate at much higher energies than the current LHC, which could, in theory, give us a definite answer about microscopic black hole production. Running at energies up to 100 tera-electron volts, this facility would probe energy scales where extra-dimensional effects should, become really clear. Beyond just searching for black holes, these experiments keep pushing the boundaries of fundamental physics, seeking evidence of things like supersymmetry, dark matter particles, and other phenomena that could totally revolutionize our understanding of the universe. Every single collision gives us new data about the deepest levels of reality. The quest for quantum gravity. The quest for quantum gravity is really at the heart of this search for microscopic black holes. It's humanity's most direct attempt to probe the elusive theory that would finally unify Einstein's general relativity with quantum mechanics. Creating and studying these tiny objects would, for the first time, give us experimental data on how gravity behaves at quantum scales. These experiments could help resolve some of the most fundamental paradoxes in physics, like the black hole information paradox that's puzzled scientists for decades. If we can create microscopic black holes and study their evaporation in detail, it might finally tell us whether information falling into black holes is truly lost, or if it's somehow preserved in the radiation they emit, and the implications go way beyond just academic physics. Understanding quantum gravity could potentially unlock new technologies based on manipulating space-time, maybe even leading to advances in energy generation, transportation, or our understanding of consciousness itself. The microscopic black holes created at CERN might actually be the first steps toward a truly unified theory of everything. As scientists keep pushing the boundaries of what's possible, each experiment brings us a little closer to answering the deepest questions about the nature of reality. And whether or not microscopic black holes have actually been created, the search itself has already advanced our understanding of the universe's fundamental structure. So in the end, the quest to create microscopic black holes at CERN is really about more than just scientific curiosity. It's humanity's attempt to probe the deepest levels of reality itself. Whether these quantum-scale phenomena have been successfully created or, still remain tantalizingly out of reach. The search has already revolutionized our understanding of space-time, extra dimensions, and the fundamental forces that govern our universe. As technology keeps advancing and new experiments push ever deeper into the quantum realm, we're edging closer to answering the ultimate questions about existence itself. The universe's deepest secrets may finally be within our grasp.